All right, so last bit here. This is a lot here on this initial slide, but it's referred to as Le Chatelier's principle. Okay, we've talked about not this specifically, but we've said, hey, products dominate or reactants dominate, and that affects your big giant K. And we've also said, hey, yesterday we looked at Q. Is that at equilibrium, or which way does equilibrium need to shift? Now we can talk about, okay, what happens if we are already at equilibrium and we either add stuff or take away stuff? What's going to happen? And so we refer to these as shifts. Okay, if we add something, it's going to shift one way. Okay, our shifts in general, we're going to say shift left, and what we're referring to is the original reactants. If we say shift left, if we say shift right, it is going to be the original products. All right, so shift left, reactants, shift right is our products. Okay, now we're going to go through these, and it's just easier to see in an example here, but so you have a reference. That's why we have this slide up here. Le Chatelier's principle says change in concentration, aka if you add or take away stuff, okay, a reactant or product. When I say stuff, if you add, you increase, you're going to shift to the opposite side. Okay, so if we add something that's original reactant, we have to shift opposite. We would shift to the right. If we take away, we decrease that substance in the equilibrium mixture, we shift to the same exact side that we took it away from. Pressure. We have kind of sort of talked about this. I don't really get into pressure because we haven't talked about our actual gases unit, but our pressure. If we increase the pressure, think of like a balloon, right? We squeeze it, it's got to relieve itself. So it's going to relieve itself to the side with the least number of moles of gas. If we decrease pressure, again, goes to the most size of most moles of gas. Temp, increased temp, it's almost, I don't want to say it's like a reactant or product, but it acts like this in this process. If we increase temp, it shifts to the opposite side that heat is on, which we'll talk about how and where we can add heat. If we decrease temp, it shifts to that same side that the heat is going to be on. And again, heat is not a reactant or product. But for this process, we're going to view it in that light. And then a catalyst here, major thing, does not affect equilibrium. It just helps us get there faster, right? It gets us to that point so we don't have to wait around for the equilibrium to be established. Questions? Does anybody still need this? One thing. I got it. Good. I got it. What's yesterday? What? All right. So here we go. So we have our example. The easiest way to go through this is examples. And so I'm either going to say shift left, and what I'm saying shift left is the left-hand side with nitrogen and hydrogen, or shift right with NH3 or ammonia. Okay. So we are increasing the following items. So if we increase our N2, so right now our N2 on 1A is going up. It shifts opposite sides. You add N2, it shifts opposite. We would say that the equilibrium shifts to the right. Okay. Now we add H2. If we add H2, it shifts opposite. What's the opposite side that H2 is on? Okay, so we'd say shifts right. And now on NH3, It's on the right, so it shifts opposite. So it shifts to what side? Okay, too easy. Okay, questions? Does anybody need this? Okay. All right, so here we go on this. Now, still changes the concentration, but now we're decreasing. Okay, so we do the same exact route here. We go through this and we say the following. Now we are lowering our amount of N2. If we lower or we take that away, it shifts to the same side. So because N2 is already on the left, we say this will shift left. H2, again, originally on the left, we take it away, shifts to that same side. So again, we see shifts left. And then NH3, if we take that away, it shifts to the same side that NH3 is on. So we shift to our right. Okay. Questions on this? Does anybody need it? Add it, shifts opposite. Take it away, shifts to the same side. That's the big takeaway. Okay. Now, going through our next equation. We keep the same equation, equilibrium mixture. Now we're dealing with pressure. So before we even get to the details here, I'm going to add our total moles of gas up. And I'm going to shift colors here. I'll use green. Our total number of moles simply comes from adding our coefficient. So there's no coefficient listed in front of N2. We assume 1 plus 3. 1 plus 3 is what? So on the left, we have 4 moles of gas. On the right, there's only one item has a coefficient of 2. So how many moles of gas? 2. When we talk about pressure, we have to think in this nature. Okay? In this, we now increase the pressure. So we got to relieve ourselves, right? We have to relieve ourselves. Imagine a relief valve. If we increase pressure, we have to shift to the side with the least number of moles of gas. Which side has the least number of moles of gas? Right. So we say shifts right because it only has 2 moles of our gas. Now we decrease pressure, right? So we have more room to maneuver. It shifts to the side with the most moles, which is what side? Left. Okay. Questions there? Anybody need this? All right. Now, what we do is this. So we go one step further, and now we talk about heat, which we have not talked about thermodynamics, thermochemistry. And so this, before I even get into this, I'm going to say this. I'm going to write this down on some side here. Let's use red because we're talking about heat. Okay. If we have a positive delta H, which delta H is just enthalpy, aka for us, heat change. If delta H is a positive, then heat is on the reactant side. Okay, so let me write that down. Heat on reactant or our left-hand side, if you want to think about that. Now, just the opposite here. If delta H is negative, heat is released, which means heat is on the product side or the right-hand side. Okay, so on this, delta H is more than 0. If it's more than 0, are we positive or negative? We're positive. So I like to say this, delta H equals positive. And so what side is it on? The reactant. Now, messed up. I didn't put enough room here. I'm going to put it on my left-hand side. And again, let's view it as a reactant or as a product. In this case, it's on this reactant side. So I'm going to say plus heat on this side. So we increase temperature, right? It's like increasing our concentration. So it's on, originally on the left. It shifts opposite. So we would say shifts right. It's got to relieve that heat that's added. Then we take it away. We lower the temperature so it shifts to the same side that's heat's on. So it's going to shift to our left. Questions on this? Just FYI, if delta H was negative, where would we add heat there? To the right-hand side. Okay, so just in case you see something that says this is the negative delta H. All right, questions? Anybody need this? Okay, getting close here. All right, so I have everything added here together, and I just kind of throw some things randomly, okay? First thing, I have delta H, so I'm going to go ahead and I'm going to knock this out. Delta H is positive. So once again, what side of the equation are we going to see our heat on? Very good. So I say, hey, plus heat. Now, technically, it's not a reactant, but we just view it like that for this process. So here we go. We have this. We have into O4 added. We add into O4. It's originally on the left. We have to shift it which way? Right. We got to relieve it. So we say shifts right. Then we take away NO2. If we take away that item, it shifts to the same side that it's on. So if we're taking away NO2, it's going to shift right once again. Now, pressure is increased by the addition of N2. Don't really worry about the addition of N2. Worry about the pressure is increased. If the pressure is increased, it has to relieve its side to the side with what? Least moles of gas, which is what side? Left, because it only has a 1 coefficient. So we say shifts left. Okay. Now, we didn't talk about this, but we have to think about it. All right. If we have the volume, I just use my hands as an example. The volume is increased, right? Originally, we had this big of a container. Now we have this big, all right? A lot bigger. Volume increase. What happens to pressure? The same amount of stuff is in there. Pressure, what? Pressure decreases. So I like to add this because they like to throw you for a loop here. Our pressure is going to decrease because of that additional volume. Okay, so now pressure decreases, shifts to the side with the most moles of gas. What side has the most moles? It shifts right. Yeah. All right, now temperature is decreased. View it as a substance here. So if we took this away here, we took heat away, it shifts to the same side. So shifts which way? Left. Yep. Okay. Questions?